Mr. Patterson here, and in this video I'm going to show you how to find the unknown resistance in a complex circuit. Alright, so let's find the unknown resistance in this particular circuit here. Okay, you have all the resistances listed there except for the resistor on the far right there, R00. Okay, so the whole idea that I'm going to go through is I'm going to take this complex circuit, I'm going to simplify it, find some information about the unknown resistance, and expand it back out so I can finally isolate resistor 0, 0. Okay, so in order to simplify it, what I'm going to do is say, hey, this area right here, all three of those resistors, they are in series. So I'm going to call that collection of resistors R01. Okay, so then the circuit will then look like this. Okay, so I've got the 6.81 ohm resistor and R01 in parallel with each other. I can simplify that. I'm going to call that collection of resistors R02. Okay, now I can get to work once I have it simplified this far. So I've got three resistors that are in series with each other, pretty easy to work with. So the sum of the individual resistances is the total resistance. So I know the equivalent resistance is 21.50 ohms. All right, that's the sum of those three. So that means resistance 2, R02, is 4.9 ohms. All right, now I can start expanding back out. Once I know what R00 or R02 is, I'm going to work backwards here. Okay, so I've expanded R02. And I say R02 is equal to 1 over 1.68 ohms plus 1 over resistance 1, which is now in the expanded form of this circuit. I will isolate R01 by substituting in R02. And I will find that R01 is 17.47 ohms. Once again, I'm going to expand it back out, substitute in R01. All right. So R01 was the collection of resistors on the far right-hand side here. They're all in series. I know that it's equal to the sum of the individual resistances, which I have written down here on the bottom. Okay, so now it's just a simple matter of substituting in R01 and isolating R00. And when you do that, you get 4.77 ohms or 4.8 ohms when it's rounded. All right, big idea here is you take something that's very complex, simplify it into something that's more manageable, and then expand it back out to solve for every individual resistance.